Okay, now we're doing 2014 question 16, which is the last question in that paper. So 10 marker, and let's see how easy that is for a last question. So starts off saying express -1 as a complex number in polar form. So whenever you want to change something from Cartesian form to polar form, you want to sketch it on an Argand diagram. So -1, real, imaginary. So say we say z equals -1, it's really -1 plus 0i, or I0. There's no imaginary part to it. So -1 is just along here. So the modulus is that distance there, which is 1, and the argument is that angle there, which in this example it's 180. Okay, so in polar form, z is going to equal 1 bracket cos 180 degrees plus I sine 180 degrees. And that's it in polar form. Okay, it then says, hence determine the solutions to the equation z to the 4 plus 1 equals 0. So if z to the 4 plus 1 equals 0, that means z to the 4 equals -1. Okay, so -1 is z that we've just already had. Now we've already written that in polar form, so z to the 4 can equal cos 180 degrees plus I sine 180 degrees. Okay, and we don't need the modulus because the modulus is 1. So if that's what z to the 4 is, and we're trying to work out the solutions to that, we're trying to find the solutions, so we want to work out what z is. So z is going to be this to the power of a quarter. So you're using your de Moivre's theorem again. Now remember, de Moivre's theorem means that the modulus gets multiplied to the power, in this case it would be a quarter, and the argument gets multiplied. Now because our modulus is 1, 1 to the power of anything is still 1, so we don't need to worry too much about that. So all we need to do is multiply our arguments, in this case, by a quarter. Okay, and we know that a quarter of 180 is 45. So that then just becomes cos 45 degrees plus I sine 45 degrees. Obviously you can do it in radians as well, but remember in degrees to actually put the degree symbol in. Okay, so that we can change back into Cartesian form by just working out what cos 45 and sine 45 is. So we know that cos 45 is 1 over root 2, and sine 45 is also 1 over root 2. So plus 1 over root 2i. Now that is just one of the solutions, okay, one of the roots. Because if you've got z to the power of 4 and you're finding all your solutions, you're going to have 4 solutions. So that's like z to the 1, we could call that z to the 1. Now the rule for finding all of your roots is that you're going to get 4 of them, and they're all going to be plotted on an Argand diagram equally spaced around a circle. So we know that a circle is 360 degrees. If I'm looking for 4 solutions, then equally spaced 360 divided by 4 is 90 degrees. So what I want to do is going back to this original answer here, which is that one there in polar form, okay? We want to be adding on 90 to these two arguments to get our other solution, okay? We want to also subtract 90 from them as well, okay? We want to make sure that we don't go above 180. Your arguments go from there to there, which is 0 to 180, and then they go from there to there, which is 0 to minus 180. So they have to range between positive 180 and minus 180, okay? So we add and subtract 90 onto the argument until we get our 4 solutions, but not going above 180 or below minus 180. So Z2, I'm just going to add 90 on to 45, and it will be cos 135 degrees plus I sine 135 degrees. Okay, so that's in polar form, but to change it back into Cartesian form, I'm just working out what those are. So cos 135 is minus 1 over root 2, and sine 135 is plus 1 over root 2. Okay, so that's our first 2 solutions. So I'll just move this up a wee bit. So my third solution, okay, Z3. Now, if I added on 90 to these arguments, that's going to take me above 180. Okay, so what I want to do is go back to my 45 and this time take away 90 from 45. So if I take away 90 from 45, I'm going to get minus 45 degrees plus I sine minus 45 degrees. And again, putting that in our calculator, we get 1 over root 2 and minus 1 over root 2i. Okay, so I'm going to keep subtracting 90. So if I subtract 90 from this root to get Z4, then I'm going to get cos of minus 135 degrees plus I sine minus 135 degrees. And working out what that is, it's minus 1 over root 2 minus 1 over root 2i. So just to recap, once you've got your first solution, because it's a power of 4, there's going to be 4 solutions. The solutions, if plotted on an Argand diagram, are equally spaced around a circle. So because it's to the power of 4, 360 divided by 4 gives you 90. So you're adding and subtracting 90 onto your first root or your first solution, so that your arguments all lie between minus 180 and positive 180. Okay, and then once you've got them in the polar form, you're just sticking them into calculators to get what it is in the Cartesian form. Okay, so that's all the solutions to that. Now that was the solutions to z to the 4 plus 1 equals 0, and then part B is asking us to do the same thing with z to the 4 minus 1 equals 0. So I'll just rub all of this out and we can do that now. Okay, so z to the 4 minus 1 equals 0 means that z to the 4 equals 1. So if I plot that on an Argand diagram, this time it's looking like that. So the modulus is still 1 and the argument for this one is 0. So in polar form, z to the 4 is going to be 1 because of the modulus cos 0 degrees plus I sine 0 degrees. Okay, and then if I want to get my solutions, z is going to be that to the power of a quarter. 1 to the power of a quarter is still 1, so I'm not going to even bother putting that in. And then if I multiply 0 by 4, I still get 0. Okay, so the first solution is going to be that. Okay, if we work out what cos 0 and sin 0 is, we can change that into Cartesian form. So we know that cos 0 is 1, and we know that sin 0 is 0, so z equals 1 is your first solution. So we'll call that z to the 5, so that it's different from our previous roots. Right, so z6 is our next root, and because it's to the power of 4, we're looking for 4 solutions here. And again, just like in the previous question, 360 divided by 4 is 90. So I'm adding and subtracting 90 on to the first solution's argument. So cos of 0 plus 90 is 90 degrees plus I sine 90 degrees. And then I'm just working out what that is. Now cos of 90 we know is 0 and sine 90 is 1, so that's just going to be plus I, so I is a solution. Z to the 7, if I add on 90 to 90, I'm going to get cos 180 degrees plus I sine 180 degrees. And we know that cos 180 degrees is halfway through, which is at -1. And we know that sine 180 degrees halfway through is 0. So -1 is also a solution. Z to the 8. Okay. If I add on 90, it's going to take me above 180. So I'll go back to my original 0 and I take away 90. Okay. So I'm going to do cos of -90 degrees plus I sine -90 degrees. Okay. Now, if we think of our cos graph, remember cos is an even function. So cos of -90 is the same as cos 90. Okay, so cos 90, so that's going to be 0. And sine is an odd function. So sine -90 is going to be the same as minus sine 90. So that's going to be minus I, because it's -1. Okay, so that's just minus I. So our roots are 1, -1, I, and -I. Okay. So then we're going on to part C, and it's saying plot the solutions of both equations on an Argand diagram. Okay, so we'll do that now. So real, imaginary. So from part A, we had 1 over root 2 plus 1 over root 2i. Okay, so if I just put 1 over root 2 and 1 over root 2, so that was our first solution, which we labelled Z1. Z2 was minus 1 over root 2, 1 over root 2i, so that goes there, and that's Z2. Z3 was 1 over root 2 minus 1 over root 2i. Okay, so that's Z3. And Z4 was minus 1 over root 2 minus 1 over root 2, which goes there. And then for part B, our solutions were 1, -1, I, and -I. Okay, so if we say that that's 1 there, that, I can't remember the actual numbers, but let's say that was Z to the 4. Then we had a -1, which we'll call